Hey everyone, I hope you're doing well today. In this video, let's talk more about graphing quadratic functions. While in my last video we talked about graphing quadratic functions that were written in standard form, these quadratic functions are going to be written in vertex form. Just a quick reminder, when quadratic functions are written in vertex form, they take the form of f of x is equal to a times the quantity of x minus h squared plus k. Just like in standard form, this coefficient or constant of a is going to tell us if we're going to have a vertical stretch, a vertical shrink, or if the parabola is going to have a minimum or a maximum. A new constant that we see in vertex form is this h here. When h is positive, the vertex is going to move to the right, and when h is negative, the vertex is going to move to the left. Another new constant is this k. When k is positive, the vertex is going to move up, and when k is negative, the vertex is going to move down. When graphing quadratic functions in vertex form, we can follow these 5 steps to do so. First, we'll always begin by just identifying our a, h, and k values. Then after that, in step 2, we'll interpret what they mean. In step 3, we'll use the h value for our A.O.S. In step 4, we'll use our h and k value to create the vertex of the parabola. And then in step 5, we'll make a table and graph it. Here's a quick example. Imagine we have the quadratic function f of x is equal to negative 1/4 times the quantity of x plus 2 squared plus 5. The value of a is going to be negative 1/4, so we know there's going to be a vertical shrink here, or the parabola is going to get wider, and because it's a negative value, then the parabola is going to have a maximum and be flipped upside down. H is equal to negative 2, so the whole parabola is going to shift 2 units to the left, and k is equal to positive 5, so the whole parabola is going to shift 5 units up. Using h and k together, we know that our vertex is going to be negative 2, 5, and that our axis of symmetry is at x equals negative 2. If we were to make a rough quick sketch, we know from the origin that the vertex is actually 2 units to the left, but then 5 units up. We can plot our vertex at negative 2, positive 5 in quadrant 2. Thinking back to our a value, which was negative, we know this parabola is going to have a maximum and it's going to be flipped upside down, and it's also going to be a little bit wider than normal because the coefficient of 1/4 lets us know that we have a vertical shrink. Roughly, our parabola might look something like this. Before we take a look at this example in a little bit more detail, let's review how to understand the a, h, and k values. If a is greater than 0, then the parabola is going to open up and we have a minimum. If a is less than 0, then the parabola is going to open down and we have a maximum. If the absolute value of a is greater than 1, then we have a vertical stretch, or the parabola gets skinnier. And if the absolute value of a is less than 1, or is a proper fraction, then we have a vertical shrink, or the parabola gets wider. If the value of h is positive, then we're going to have a horizontal translation to the right h units. If the value of h is negative, then we're going to have a horizontal translation to the left. If the value of k is positive, then we're going to have a vertical translation of up k units. And if the value of k is negative, we're going to have a vertical translation down k units. The equation x is equal to h is the equation of an imaginary vertical line, which is our axis of symmetry. And the ordered pair of h, k represents the vertex of our parabola. Let's quickly go over that example that was on the screen just a moment ago in a little bit more detail so you can see this in action. So let's actually make a detailed and accurate graph for this function f of x is equal to negative 1/4 times a quantity of x plus 2 squared plus 5. This negative 1/4 that we have in front is going to be our a value, so we can say a is equal to negative 1/4. Inside the parentheses here, remember that it's supposed to say x minus h, so this plus 2 is pretty important. It means that h is actually equal to negative 2, since a minus minus 2 becomes a plus 2. As for the k, this plus 5 is just going to be normal since it's always a plus k in the formula, so k is equal to positive 5. Since a is negative, we know that our parabola is going to open down and have a maximum, and we're going to have a vertical shrink here. It's going to get wider. The plus 2 lets us know that the vertex is going to shift 2 units to the left, and our plus 5 is going to let us know that we're going to move up 5 units for the vertex. The A.O.S, or axis of symmetry, is always going to go through the vertex, and we know that's going to go through this x value of x is equal to negative 2, or the h value. And as for the vertex, we can go ahead and say that the x value, or h value, is going to be that negative 2, and then our y value, or our k value, is going to be a positive 5. Let's go ahead and make a table now. Just like with standard form, we're going to take our vertex and put it in the middle of our table, since parabolas are symmetrical. Then we'll go ahead and choose some x values on both sides of negative 2, but equidistant from it. So both these numbers are bigger than it by 1, or smaller than it by 1, and then bigger than it by 2, and smaller than it by 2. Both of the y values for -3 and -1 will be the same since they're equidistant from the -2, and I'm going to try doing the -1. Using x equals -1, let's find f of that value. Let's replace x with -1 and find out what the y value is at that location. So a little bit of order of operations here. This -1 plus 2, that's going to be +1. So we have -1/4 multiplied by 1 squared plus 5. 1 squared is going to be the next thing we'll do, and that's just going to be 1. So we have -1/4 multiplied by that 1 plus the 5. And -1/4 times 1 is still -1/4, so we'll say -1/4 plus 5. Then we have -1/4 plus 5, or just 5 minus 1/4, and that'll be +4 3/4. So when x is equal to -1, we know that y is going to equal 4 3/4. Going to go ahead and write that right in our table there, and it's going to match for the -3 since it is symmetrical. Now let's try this again, but with our other value so we can fill in our table. Between the x equals -4 and the x equals 0, I think the 0 is going to be a little bit easier, so let's find f of 0 to find the y value. Substituting in 0 for x, let's find out the y value. So based on the order of operations, we'll do the parentheses first. So we have this -1/4 on the outside. 0 plus 2 is going to be 2, so we have 2 squared, then this plus 5. We're going to do the exponent next, and that's going to be 2 times 2, which is going to be +4. So I'll write that as 4/1, just so it's easier when we multiply the fractions in just a moment. These 4's can cross cancel. 4 times 1/4 is going to be 1. Since it's negative, we'll have a -1 here instead. We just went ahead and did the multiplication. We're going to add the 5 on afterwards. -1 plus 5, well, that's just 5 minus 1, and that's equal to 4. So when x is 0, we just found out that y, or f of x, or f of 0, is going to equal 4. Go ahead and put that into our table. So we have 5 ordered pairs now. Let's go ahead and sketch a graph. On our xy plane, let's start with drawing the A.O.S, or the axis of symmetry, which is a vertical line of x equals -2. Here's our A.O.S, and this equation is x equals -2. Our vertex is -2, 5, so that's 2 units to the left and 5 units up, so it's going to be right on our vertex, right about here. Plotting the point -3, 4 3/4, that's right about here. And then the -1, 4 3/4 is going to be symmetrical on the other side, right around here. Then we have -4, +4, which is located over to the left. And then we have 0, 4, which is our y-intercept, and we'll put that equidistant on the right. Drawing a smooth curve through each of these 5 points. Here's a pretty accurate sketch of the parabola for the function f of x is equal to -1/4 times a quantity of x plus 2 squared plus 5. Since our a value is -1/4, that the parabola is upside down, and it's a little bit wider than normal, or there was a vertical shrink. Hopefully you found this video helpful on understanding how to graph quadratics when they're written in vertex form, and if you'd like to see some practice problems, stay tuned for another video that will be uploaded in a few days. As always, keep up the great work, and I'll see you in the next one.